Good morning, everybody. This is a live emergency update from Team Dominator headquarters here. We've got the Chase Like a Champion Today poster up on the wall, and we have the beginning of the second season for severe weather coming up tomorrow, Wednesday evening, possibly even the threat of a significant tornado or two. And that is going to be basically from Oklahoma City up to Wichita. Low-level jet is going to intensify. Anytime you get a low-level jet up near 50 knots with perfect wind shear profiles and supercell storms moving into that, usually that means that you get a threat of tornadoes. And this upper-level trough is amplifying. It's getting stronger with every single run, and that has led to a bit of a triple point that's forecast to move from southern Kansas into northern Oklahoma, and that could enhance the wind shear even more. So the Storm Prediction Center has a 5% area for tornadoes, and that includes the I-35 corridor all the way up. And I'm going to break down this entire setup here, including the low-level jet that is just a expansive low-level jet. That's the southerly wind about a kilometer above the ground that causes supercell storms to tighten up at the low levels and produce tornadoes. And we do have an incredible moisture return underway so far this morning. Nothing smells better than a low-level jet in the morning. And look at these big-time dew points here. We are even talking about upper 60s dew points up in Team Dominator headquarters. I had somebody say yesterday that it looks like a little kid drawing on maps, and they have no idea what I'm even saying during these live updates, but I'm just going to continue to sling these live updates and continue to be technical, because eventually, after you hear them over and over again, eventually it all makes sense. And you've got a 64 dew point here in the Oklahoma City metro down to Norman. You've even got some deeper dew points up across this area, south central Oklahoma into eastern Oklahoma. Team Dominator headquarters, we're cooking at about a 65 dew point there. So major dew points happening here. And let me show you the dew point temperature rise. This is from Norman, Oklahoma. You can see that dew point temperature in green compared to the regular temperature there in red. And look at that. That is a steady rise up into the mid-60s. Yesterday had dew points more into the 40s. Even some critical fire danger yesterday as some of that moisture was getting a little bit lower here in Oklahoma. That's just ahead of a trough. Those southerly winds start to ramp up, and then eventually they transport that moisture northward, and we had a bunch of condensation so far this morning. You had the decoupling process here yesterday evening. Sun goes down, dew point sloshes upward, and so far this morning at about 9, 10 a.m., we're talking at about a 63, but you had that rise yesterday evening, steady rise of the moisture transport driven by the low-level jet that's out there, and that new moisture is just dominating right now. So we are going to break down the trough shape. First, though, we'll just cut right to the chase, cut right to the MPAS model, and this is at 0Z tomorrow. You've got a cold front that's going to be surging to the south, northerly winds back behind it. Dew point temperatures actually rise a little bit behind the front up here in eastern Kansas into Iowa. And then you have a dry line that extends to the south of that, and behind that, very dry conditions, single-digit dew points into the teens back behind it. And then to the east of that, you have deeper moisture, mid to upper 60s dew points. And it looks like they actually pool just ahead of that that secondary surface low, moving from southern Kansas into northern Oklahoma, a little bit of some pooling of the moisture. But you have the triple point that sets up right here. That's your intersection of the cold front, dry line, and warm front to the east of it. In this case, it's kind of more of a cold front extending to the northeast of that, maybe more of a stationary front. But usually, with a stronger surface low like this, you'll get a stronger low-level jet, a little bit more backing of the surface winds, and you actually get some enhanced low-level wind shear ahead of those features. And all of that is driven by the upper-level trough. And let me also show you here that we have got the MPAS model, which I think is going to become the HRRR, actually shows the evolution of these supercell storms near the triple point. Initially, these form on the dry line, western Oklahoma. Also could have an I-44 ripper down there as that low-level jet intensifies. But the MPAS model actually blossoms this area into some supercell storms that are going to have some tornado threat. Just to the east of that triple point, you're going to have some enhanced low-level wind shear, and I do think that those storms are going to have the potential of producing a tornado, maybe even a significant tornado, by about 6 p.m. And right now it looks like southern Kansas and in northern Oklahoma seems to be that zone. But notice as you go from 5 p.m. to 6 p.m., these really mature across northern Oklahoma. You get a handful of supercells that really mature out there, and they are going to be moving into an environment with very strong wind shear as well. And I do think that we are going to have the threat of even a significant tornado or two. Let's zoom in just a little bit here on this MPAS model. We're watching those two storms that could evolve, and looking at a forecast sounding just ahead of those storms near Osage County. We will look at the HRRR model to pick those. But it definitely shows your triple point well. See these westerly winds back behind the dry line, northerly winds back behind the cold front. Cold front catches the dry line, and eventually the whole cold front is just going to steamroll through eastern Oklahoma, eastern Kansas, even the Kansas City area by tomorrow evening. But let me show you the low-level jet that ramps up here on this model. We can use the 0 to 1 kilometer SRH. And notice how at between 6 and 7 p.m., those brighter colors get a lot closer to those handful of supercell storms into northern Oklahoma. We actually have stronger wind shear eastern Kansas into northwestern Missouri, including the Kansas City area. So any supercell storms are going to be able to move off that front even further north will have the potential of producing a tornado or two. And it does look like that front is actually a little bit more meridianal, more north-south oriented. But the upper level winds up here largely parallel to that frontal boundary. So storms are going to have a very difficult time moving off that cold front from eastern Kansas up into northwestern Missouri up there, including Kansas City, back toward Wichita. But from Wichita down to Oklahoma City, this is where you're going to have the potential for supercell storms in an environment with an intensifying low-level jet. Classic Southern Plains type of a setup. The upper level trough is not shaped perfectly, though. I'm going to get into that here in a little bit. But look at your significant tornado parameter as well ahead of these supercell storms. You have your anvil shadows there kind of carving out that instability just a little bit. That's the high cloud with the storm that gets pushed downstream by the upper level winds. That leads to an erosion, just a little bit of that instability. But you can see that there's a lot of strong wind shear, plenty of surface-based instability, eastern Kansas, even all the way up into northwestern Missouri. But you can definitely see where that triple point's located down here. Southern Kansas into northern Oklahoma. And we are going to be activating the Dominators for this one. Team Dominator is going to be back out there. Looking at your updraft helicity tracks, the MPAS model is definitely honing in on a couple of long track supercells, possible tornado producers that move through northern Oklahoma near the Kansas-Oklahoma border. Packed up nice and tight up to that triple point there in northern Oklahoma, but could get some long trackers moving southwest to northeast right there. Also looks like some elevated storms that could move from eastern Kansas up into the Kansas City area. Those will also have some isolated tornado potential, but the greatest tornado potential, southern Kansas, northern Oklahoma, maybe even down to the Dallas area potentially. But let's take a look now at the HRRR model, which does seem to be mixing out the dew points a bit. The HRRR model also has this long track supercell moving from central Kansas all the way up into the Wichita area. And it has a little bit less central into northern Oklahoma, just a little bit more meager. This happens a lot during the late season, where the convective allowing models will underdo storm coverage a little bit. And if anything, that's telegraphing the potential for isolated supercells northern into central Oklahoma. Looks like also a long tracker there, possibly into southeastern Kansas, which should be right along that triple point. Definitely a lack of those helicity tracks further south, but I do think that there is a decent chance of an I-44 ripper coming right up I-44 southwestern Oklahoma into central Oklahoma. Watch what the 0 to 3 kilometer NAM is showing, which does a little bit better of a job with moisture, and it shows a couple of these storms trying to evolve to the southwest of Oklahoma City near that favorite area of I-44 that moves out of southwestern Oklahoma, eventually into central Oklahoma. We're just going to have to keep a very close eye on those as well. That's at about 7 p.m. 3 kilometer NAM definitely hints on an undercut squall line moving from eastern Kansas into the Kansas City area into southern Iowa, and a bit more isolated development further south, western into central Oklahoma. And definitely the potential of supercell storms impacting even the Oklahoma City metro by like 8 to 9 p.m. Moving out of this area, southwestern Oklahoma, right along I-44, eventually potentially impacting Oklahoma City metro. But you can definitely see here on the 3-kilometer NAM, the high-resolution NAM model, that you can even see a little ribbon of some outflow or a cold front that is advancing east. And it looks like a lot of this convection is a little bit elevated behind that advancing cold front. That means it's elevated above a little shallow stable layer there across eastern Kansas. So I think you're going to see a couple of different modes. Supercell storms off to the south from that triple point down into central Oklahoma, and then a forced squall line eastern Kansas up through Kansas City. And I do want to look at the trough shape. Normally here at Team Dominator, we start off our forecast with the upper levels, which is exactly what I did this morning before I went live. And you can even see that with this forced squall line oriented southwest to northeast, that it is parallel to the upper level flow largely, and that is due to a slightly unfavorable trough shape to get a more significant tornado outbreak that might happen. You go up to 500 millibars, and you can definitely see, even though we have a deeper trough with a bit more of even a negative tilt from that vortex over western South Dakota, it looks like it's trying to develop a more amplified western tilt. So it definitely has trended toward a less flat trough, and that's why we have that stronger surface low. But all along this cold front, eastern Kansas up to Kansas City, notice how the upper level flow is parallel to that southwest and northeast oriented warm cold front. But the dry line that's oriented more north-south from western Oklahoma into central Oklahoma, look at how the upper level winds are oriented at more of an angle to that dry line. And that's why the dry line is going to be a more effective initiator of supercell storms down a little bit further south, western into central Oklahoma here. But that's where it looks like it's likely going to happen. Central, western Oklahoma, forced squall line with better kinematics, even stronger low-level wind shear across eastern Kansas into northwestern Missouri. But what I mean by a slightly unfavorable trough shape, usually you need a little bit more flow on the backside of the trough for it to be amplifying as it ejects from the Mountain West. And this one has a lot of flow on the eastern side of the trough. That means it's a little bit past its peak. It was amplifying further west across the Mountain West, but as it gets to the Great Plains, it is flattening out a little bit and has a lot more flow on the eastern edge of the trough. You've got kind of this weird positively tilted ridge out ahead of that. And that is kind of a blocking high, creating a lot of drought conditions, a lot of dryness across Dixie Alley and the southeast. That has definitely caused below normal severe weather over the last couple years, but it's been focused across the Great Plains and Tornado Alley. And I've always been a believer that Tornado Alley is here to stay because the Gulf of Mexico is a permanent body of water. The Mexico Plateau, elevated plateau out there, is permanent, as are the Rocky Mountains and the Great Plains, a gradually sloping terrain from east to west. That's why it's such a unique place for those strong low-level jets. And look, as I go to 850 millibars, we have a very broad low-level jet, but it peaks up here to the east of the cold front. That's because of that slightly asymmetric shape of the upper level trough. And if it had a little bit more flow on the backside as it ejects from the Mountain West, then you'd have a stronger, more backed low-level jet across Oklahoma. And we'd likely be talking about more of a tornado outbreak down here, including Oklahoma City to Wichita. But I still think that we could get a supercell or two long track capable of producing a significant tornado, central Oklahoma up toward Wichita, including Oklahoma City and the Wichita area. And I do think that it does have the potential of being upgraded to a slight risk, but I wouldn't focus on that too much. I do think that a slight risk and a 5% is probably perfect to account for the isolated risk of isolated supercells moving through northern Oklahoma, southern Kansas along that triple point. Thank you, Ben. Yeah, I mean, the event hasn't happened yet, so of course it's possible there's not going to be a tornado anywhere. But if you say there's not going to be a tornado nowhere, that's more of a double negative, and that means that you're saying there's going to be a tornado. So Definitely got to be careful with those double negatives because -1 times -1 equals a positive, folks. And there is a chance of even a significant tornado, southern Kansas, northern Oklahoma, possibly down to the Oklahoma City metro. I don't think it's going to be an outbreak of a bunch of weak tornadoes by any means because of that strong low-level jet that's in place. So I think that if there is a tornado, it's definitely going to be capable of being pretty strong and damaging. Some limiting factors are that the core of that low-level jet is a little bit stronger to the east of that cold front that's advancing from eastern Kansas through Missouri, southern Iowa. But when you're talking about tornadoes, and everybody that's from the southern plains here knows what I'm talking about, you're talking more about potential out there. And the environment is definitely supportive of a tornado or two. All right, so I focus on the high ceilings out here. Looking at the regular NAM model, check this out. The regular NAM model even has a stronger low-level jet, trending from 60 to this morning. Look at that down here across Oklahoma, southern Kansas into northern Oklahoma. You've got a 40 to 50 knot low-level jet there. And I'm going to take a look at some soundings and show you that potential. It's not going to be a tornado outbreak, but if a couple of supercells are able to evolve across central into northern Oklahoma, then I do think that it has the potential of being a significant tornado, especially if any can evolve near that triple point. And if that triple point can hang on for a little bit longer, basically you've got this little lobe of 850 right there into south central Kansas. To the east of that, you've got a low-level jet that accelerates about 50 knots. You're looking at about 7 p.m. So look at this slug, a 50-knot, 1-kilometer wind. That's oriented out of the due south right there. And if that's over top those south-southeasterly surface winds, it's a little bit of directional shear, a little bit of speed shear as well. You've also got this little push in westerlies back behind it, slamming right into that triple point. All of it points toward the maintenance of this triple point, southern Kansas into northern Oklahoma, and also a dry line coming into western Oklahoma. Wouldn't be surprised, a lot of times you get a storm that comes right up the I-44 area there, southwestern Oklahoma, pushing its way into the Oklahoma City metro. But I'm definitely concerned about this strong low-level jet. We'll look at a forecast sounding there just to the east of Wichita, and we've got a PDS tornado sounding. You've got your elevated mix layer. That's a dry slot in the mid-levels. That erodes some of the cloud cover out there, and it's very important, very critical to get that dry over moist type of a profile when you're talking about tornadoes, and all of that is driven by that mid-level dry slot that comes off the Mexican plateau. That acts to steepen the lapse rates with the red line, with the rate at which temperature decreases with height. And that's all over top this moisture. You've got mid-60s dew points on the NAM. Temperatures warming up into the middle 70s. Your convective temperature here, which is basically the temperature that needs to be reached to get a pure surface-based storm to breach that cap. Your convective temperature is 77 degrees just off screen. And on the upper right-hand portion of your screen, look at that frickin' hodograph up there. That is very supportive of even a strong tornado. You've got a very strongly curved hodograph there. You've got a south to northeast storm motion at about 45 knots. So these storms are going to be cooking in this environment. And look at the directional shear. Look at that low-level jet, 50 knots just above the ground, over top those southeasterly surface winds. You've got a south-southwesterly low-level jet at about 50 knots, and you have a very strongly curved hodograph there. That creates a lot of storm relative inflow. If you're moving along with that storm at about 45 knots, you're pulling in inflow with those due southerly surface winds at the surface. It's a very long storm relative inflow vector, and you're really pulling in inflow throughout the lowest kilometer of the storm. So it is going to be crucial to have a surface-based storm to generate that tornado potential. Looks like a little bit of cloud cover too, near 0Z. Some low-level clouds happening with that isentropic lift as that low-level jet is starting to intensify. But with this strong low-level wind shear, any mesocyclone is going to be capable of drilling down to the surface through the action of dynamic piping, as we call it. That's when you have a pipe of low pressure spinning cyclonically, getting closer and closer to the ground. You get lower pressure that forms below it, and through a drill action, it gradually gets closer and closer to the ground. And I've seen so many tornadoes form at cloud base where you get that dry air that cuts into the mesocyclone, tightens up the vortex within that mesocyclone into a subvortex. And when you get shear profiles like this, indicated by that hodograph, if you get any surface-based storms that develop within that environment, they're going to be more than capable of producing tornadoes. can see that low-level jet kind of accelerate just to the east of that triple point as being depicted by the NAM model right about here, southeastern Kansas and northeastern Oklahoma. We just looked at a forecast sounding just ahead of that triple point, just east of the Wichita area. Pretty good extension of that low-level jet down into central Oklahoma as well. But that is a strong low-level jet, 50 knots, 40 to 50 knots right there. Central Oklahoma into southeastern Kansas. Definitely looks like there is a threat of a significant tornado or two. Let's take a look really quick at the 3-kilometer NAM. See what it does with that feature. 3-kilometer NAM has a little bit less of that triple point, more of just kind of a front crashing into the triple point, pushing that triple point back into northern Oklahoma. Looks like a little bit less in the way of low-level wind shear there into southern Kansas. So we don't want to just hang on to that one model, but there is the HRRR model. Definitely shows the strongest wind shear kind of nosing into northeastern Oklahoma, Osage County, I-35 corridor, K County, Perry area, up into northeastern Oklahoma. Looks quite favorable tomorrow evening for supercell storms capable of producing tornadoes. And that threat is going to exist all the way down into central Oklahoma. Even though that low-level jet is more pink and less red in color, that's still a strong low-level jet. South of where that triple point sets up, you're going to have a front heading south, and that's going to push that triple point down into north central Oklahoma as that front crashes into eastern Oklahoma. So I'm definitely trying to beat this fall plague. If you guys haven't catch this, you do not want to catch this thing. The fall plague is rough, but I have an immune system that can defeat it. We've got Halloween coming up in 2 days. That's going to be Thursday. So this Wednesday night event looks like a Halloween ripper of a severe weather event. Yeah, watch out for that dynamic pipe roadster, Jim. See in the chat coming in here. Thank you, Team Dominator members, for making these updates possible. I'm going to be doing a lot more of these for Team Dominator members only throughout the off season, going through my secret sauce forecast method. Most of it just involves low-level wind shear, hodograph shape, storm mode, and pattern recognition. So you look back at trough shape, upper-level trough shape, and look for those trough shapes that lead to bigger severe weather. Here is the HRRR forecast convective evolution, and it definitely is oriented southwest to northeast, all the convection. And that is generally related to that slightly unfavorable trough shape that we have been discussing. Tuesday night, late night tonight into Wednesday morning, there's a small but very non-zero chance of a tornado potential northwest Oklahoma to southwest Kansas. But I don't think you're going to get any storms up there. But it does look like there's going to be some decent moisture return, a dry line as well. But I don't think the moisture is going to be quite deep enough along that dry line. But we could get the development of some elevated storms out there, especially northwest Oklahoma to southwest Kansas. But look at that pop in the 0 to 1 kilometer energy helicity index. So we're going to have to keep an eye on that. We also have the tropics that we need to watch. But we are focused on the second season, at least for this next week. And as I mentioned, this trough, not as conducive for a major outbreak because it has all of this flow on the east side of the trough. But a lot of times during the late season like this will lead to bigger Dixie Alley severe weather because you kind of get a fanning out of those favorable kinematics over top some decent moisture. But because we have this high pressure that's dominating Dixie Alley and across the southeastern U.S., that limits the moisture. It's very dry across the central and eastern U.S., and that has held the severe weather at least the last couple of years across the Great Plains. But I think with the maturing La Nina coupled with that warm North Pacific oscillation, we could see a severe weather season not dissimilar to 2011 coming up in 2025. We've got this next system coming into the Pacific Northwest that we have to keep an eye on. That's also going to amplify by early November and probably create some more significant severe weather. Watch what that trough does as it just takes over the entire western U.S. Massive megatrough there, more significant than even the current megatrough out there, folks. That is a large-scale trough across the western U.S. That's going to have multiple days of severe weather, possibly even happening this weekend. I know Jordan Hall and I are supposed to go see Creed, but it does look like on Friday we might have a low-level jet that is just starting to develop, bringing that moisture up near the high plains Friday into Saturday. Looks like we have another threat of some severe weather on Saturday. So look at that large-scale low-level jet that develops across the southern plains. This is on the western edge of that mega high that is still dominating the eastern U.S. and Dixie Alley. That will probably end up blocking the southeastern U.S. from impacts from that tropical system down there, which looks like it's going to go more of a due right direction up toward Hispaniola. But look at that large-scale low-level jet that develops ahead of that mega trough, like November 2nd into 3rd. Watch that puppy just eject next weekend. Oh, wow. Look at all this flow on the backside of that trough, everybody. Look at that. That is some big-time flow on the backside of that trough. This is exactly the opposite of tomorrow's system. That is an amplifying trough as it's ejecting out of the Mountain West, going crazy right there with all that flow on the backside of the trough. All of that flow is going to wrap around the base of this trough, continue to amplify it through the action of shear vorticity, deepen it through the Four Corners region, pivot around the southern plains, and that's going to create some big-time severe weather. You're looking at November 3rd right here, folks. This just looks absolutely asinine right there. Central Oklahoma, Kansas, southern Kansas and Oklahoma, the Oklahoma City corridor, I-35 corridor, low pressure, eastern Colorado. Look at these northerlies off California, telegraphing the winter season it's going to be across the Mountain West. You're going to have a big-time snow season out there across the Mountain West, including skiing, which I plan to do a lot this winter. If I can even survive this freaking second season that is upon us here. This is a big monster low-level jet coming up next Sunday, folks. Right there. And we go a little bit forward to next Monday. Possibly could start to pivot toward Dixie Alley. But boy, this high pressure is just hanging on across the southeastern U.S., making it impossible for any of those troughs to advance. But as La Nina continues to organize, I think you're going to see these big megatroughs be a lot more progressive, meaning that they're going to go more rapidly from west to east across the country. And I do think that that's going to push that. Eventually, that's going to break down that high across Dixie Alley. And eventually, you're going to see that severe weather invade this area, possibly around November 4th. But look at that, big-time severe weather. We are going to have to live stream this entire thing, folks. It tries to push into Dixie Alley, but notice how a lot of the flow is on the east side of the trough as that high pressure kind of gets compressed off the southeastern U.S. But it looks like at least a lot of heavy rain from the southern plains across the central portion of the U.S. Another system coming back behind it. You can see how we just continue to get that western U.S. trough to reinvigorate there. That's why that warm North Pacific oscillation seems to just continue to proliferate severe weather season. We're even going to have a closed low out here across the Mountain West. Bit of a subtropical connection continuing this incredible tornado season. Gizmo is back at my mom's place right now, so she's unfortunately not going to be able to experience these tornado chases, and she is pissed. But that November 2nd, 3rd, and 4th system looks to even be more significant. You can hear the tone of my voice as I'm going nuts. Thanks, everybody, for tuning in. Looking at the tropics, it does look like it's going to just be dominated by that high pressure. So thanks, everybody, for tuning into this live update. I'm going to keep these going. Looking out at the NAM by Friday, the NAM model also shows this massive megatrough taken in, just dominating the entire western U.S., bringing with it that southwest flow with moisture and a low-level jet pumping that moisture out of the western Gulf of Mexico across the central and southern plains ahead of this. Finally, we survived the tropics, and we can focus on this tornado potential, the finesse game of storm chasing here. But They're very powerful. We are going to be trying to intercept these directly. We are going to be rolling out some new sensors as well for this that we are going to try to drive into the tornado for testing purposes. See, this looks like the moisture is just going to be waiting for that mega trough to come in. So the moisture down in the Gulf of Mexico, central, western Gulf of Mexico, just sitting there in purple. Those are 70s dew points, waiting for that next trough to come in November 3rd, 4th, and 5th. Big trough takes over the western U.S., pumps that moisture northward, day after day of severe weather and tornado potential coming, including next weekend across the southern plains. So thanks, everybody. If you know anybody that lives in this area, be sure to share this stream. Dominate that like button. That's really the key. Dominate that frickin' like button. There's the Oklahoma City Mesonet. This is just an awesome tool that we have here in Oklahoma in the heart of Tornado Alley. When I first came down to Oklahoma in the late 90s as a freshman, I remember seeing the Mesonet and just being enthralled by all the bright colors on there, all the data coming in, the fine scale resolution of all these. This is moisture showing you even that 62 dew point up into Woodward, and then you're dropping into the 30s. But as we go through the day today with surface heating, mixing out that moisture, these will dry out even more, pulling in that dry air aloft out in the panhandle. Probably some wildfire damage out there across the high plains of the panhandle out there. It's going to be windy with that trough. There's a pretty strong pressure gradient across the plains. So I do think that there could be some wildfire potential out there across the Texas panhandle, into the Oklahoma panhandle, across that portion of the high plains. So basically, significant severe weather through early November. I have a speaking event up at Westmoreland, Kansas coming up. I'm going to be taking the Dominator up there. Very excited to give that talk to those farmers up there in Westmoreland. And then I will be headed back to do some leaf peeping across the western Carolinas. I know we've got peak color up there in that area, just hammered by Hurricane Helene. You kind of have those crazy appearances of like total tree loss on one side of the ridge, a bunch of colors, cotton candy on one side. So definitely a sad look at the colors, but also positive because it shows that one side of the mountain was untouched, still beautiful, and even one side of the mountain, even with the total tree loss, still has its natural beauty despite that rebuilding effort that continues out there. And it's important to go out there and do the leaf peeping. Definitely do leaf peeping out there because that brings a lot to the local economy that was so hammered by Hurricane Helene. Thank you, everybody, for tuning in. Hopefully I can knock out this fall sickness. You guys don't want this. Definitely is kind of a grinder of a cold, but I should be able to knock it out today, I think, with some supplements and some vitamins and maybe some exercise. So I will be ready for full-blown storm chase mode starting tomorrow evening. Departure probably early afternoon. We'll probably begin that live at about 4 p.m. Brian is changing diapers, so I have to give Brian a call. Get the live stream set up going again. Thank you, everybody, for tuning in. Big time severe weather coming. We broke it down in detail here. Thank you, Team Dominator subscribers, Team Dominator members, for making these updates possible and for making our science mission happen, which we are going to blow up in 2025. Thank you, everybody, for tuning in to this live update. Never stop chasing.